Okay, there we go. Ho, ho, ho. That's what it is back there. Ho, ho, ho. Welcome to my Christmas extravaganza. So enjoy the music, and we'll be starting the stream pretty shortly. Ho, ho, ho. Not that. Ho, ho, ho in a bottle. No, that's not it either. Ho, ho, ho! Merry Christmas! Debbie and I would like to wish every one of you a Merry Christmas and a Happy New Year.
Jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Jingle bells, jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh, dashing through the snow in a one-horse open sleigh. O'er the fields we go, laughing all the way. Bells on bobtails ring, making spirits bright. What fun it is to ride and sing a sleighing song tonight. Oh, jingle bells, jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Jingle bells, jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Snow in a one-horse open sleigh. O'er the fields we go, laughing all the way. Bells on bobtails ring, making spirits bright. What fun it is to laugh and sing a sleighing song tonight. Jingle bells, jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Jingle bells, jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Oh, what fun it is to ride in a one-horse open sleigh.
Welcome to the live stream. It's showtime, so let's go. And Merry Christmas, everybody. Good evening, everybody. How you all doing? Merry Christmas. I'm glad you all could make it in here tonight. We have a special guest, and he's going to be coming on here pretty shortly. If you want to know anything about 3D printers, this is the gentleman that will talk about it and answer all the questions that you might have. But I'm going to switch over to this one right here so you could get a full screen over here. Hello, everybody on YouTube and Rumble. We had some issues earlier, and we got them all straightened out. And I hope everything is doing good right now, because we're getting ready to bring him on. If you haven't done so already, smash that like button, and I'll put this up here real quick. All right. Thank you very much. We'll get this back on over here. Come on. Okay. So what you've all been waiting for, Logan Zimmerman is Representative Prusa Research, and he's going to be talking about 3D printers, resin printers, and everything about printing in 3D and resin that you want to know. So here he is right now.
Hey, how you doing, Tom?
All right. How you doing, Logan?
Good, thank you.
The stage is yours.
All right. All right, so just as we chatted before, I'd like to take some time just to talk about the basics of 3D printing, kind of introductory level, different types of 3D printing, from FDM printers to resin printers. So you see some FDM printers here and then resin printers here. Kind of pros and cons to the different material types, choices, resolution size. There's just some things that work better on FDM than they do on resin, and vice versa. So, and then also it sounded like some of your audience members had some questions that they had queued up, and I'd be more than happy to try and take a stab at getting those ironed out for them if I can. But for the most part, we can get started with basically the basics of 3D printing, unless you had something you wanted me to start first.
It's all yours. You could talk about whatever you want.
All right, so let's just start from the beginning. If you want to come into this hobby, or like a tool set that you can use for your main hobby, then you want to be able to know kind of where to start. And the first thing is, what type of printers do we have? And let me see if I can pull my screen up here, and I'll share a document here. We have this on our website. Is that okay? Can you see it, Tom?
Yeah, I can see it.
Okay, so on our website, you can actually get a free copy of this, so that way you can read through it yourself. I don't think we'll have time tonight to go through everything. I'm pretty sure it's like a 60-page document. Yeah. So we'll get through what we can and use this kind of as a reference to get started. But for the most part, obviously you need a 3D printer. This one right here is called an FDM machine. And this one uses rolls or spools of filament. And since I don't have my camera here with this, I'll get to a page where I can show you guys that. So basically, with the FDM technologies, you can see here that you have these spools of plastic. They're 1.75 millimeters. That's a pretty basic, like universal, especially in the maker. If it gets larger than that, it's more going to be industrial. So we'll talk about the 1.75 millimeter here. But this is plastic that's rolled up on a spool, and it's forced through an extruder. There's a little motor here, and there are images in here that can show you. This is what a blown up diagram of that would look like. The filament comes in through here, and you have a motor with a gear that pushes it through a hot nozzle. If you've ever used a glue gun, you can think about it that way, like how it pushes the hot glue through the nozzle. That's basically what we're doing here, just with plastic. And there's all kinds of different plastics. We can get into those a little bit later. But for now, we'll talk about an FDM printer, or FFF, really, is what we're supposed to be calling it. These printers take a nozzle like this, and it lays down layer by layer. You can see here bundles of plastic. This isn't exactly how it works, but for ease of visualization, you can see it laying down the plastic here. And then if you want to look at some of the prints, there's some demos here. This is an FDM model. So you can see on these, you'll have a little bit of layer lines. And so some people don't like the layer lines, but there's something called post-processing, which is basically you can sand and paint or fill and make all this go away. It's a little extra work, but usually for larger models, the FDM, let's say the different scales that you guys are printing at, I'd say HO plus, anything bigger than HO, you probably want to go with this process. One, because the resin platforms aren't as good at printing larger models, but two, time. So the plastic, because you can see the lines, you can see the layer lines on here that you'd have to sand out. Because each layer is thicker, it goes a lot faster. Here's some resin, though. You can see the detail. So anything like N scale, this would be wonderful. But a lot of probably HO as well, because there's still a lot of small things in that set. But you can see here, like, the layer lines are much harder to see. You, in person, would still be able to see them, but in these photos, it's very difficult to see any layer lines. Depending on the resolution that you use, resin printers can get really low resolution to where they're almost invisible. So some of the pros and cons to these two types of printing. So for FDM or FFF, this guy here, the strength in which you print is a little bit, it's not isotropic, which means that it doesn't have the same strength in every direction. When you look at the X and Y for the printing, and Tom, tell me if I'm getting like too out of layman's terms at any point. I'm trying to keep it simple.
Okay, explain which direction is X and which one's Y.
So on the Cartesian printer here, the X is the nozzle moving left to right, and then the Y is the bed moving forward and backwards, and then the Z height is the up and down height, which is, you can see this bar here. You can see my mouse, right?
Yeah.
Just fine. Okay, so this bar right here is moving up and down, so it's moving the nozzle left and right and up and down, and then the bed moves in and out. And your G code that you have for this model is basically the programming that the slicer gives, so that way all the travel moves, the speeds, everything, the temperatures for what plastic you're using and how hot it needs to get is all done through the G code. So your slicer program will tell it what to do. But basically, just for the pro and con of this machine, and I'll dive into the kind of workflow, so that way you know, like, from start to finish how to go. But for the most part, this model isn't as strong in the Z direction, up in height. Now, there are ways to give it plenty of strength in your design, and there's little tricks that I can provide here later. But for the most part, if you make anything skinny, let's say you're making a light post, right? And you want to put some LEDs and have it like a street lamp. Well, because it's so small and skinny, the layer adhesion on this type of printer wouldn't be so good. You would be able to snap it, and it's not going to be super strong because there's not a lot in the up and down, a lot of surface area for those layers to adhere to one another. But in the terms of something like this house, you have a nice rectangular design. The layers have lots of surface area to bond to one another, and this would be very rigid. This would be a hard piece to break. Maybe some of these 2x4 type parts of the print, if you put a little bit of pressure, you could snap it. But for the most part, this house would be very robust. Maybe the chimney would be something you want to be a little delicate around. But otherwise, for the most part, the rest of the house is pretty solid. Now, when it comes to resin, this is isotropic. So now even this little sprue for the ring here, that would actually be pretty difficult to snap. And depending on the resin type. So another pro and con, you have different material libraries for FDM and resin and different colors. So you can see here that the resin colors look just a hair washed out, not quite as vibrant. But with the FDM, this is not a good picture, but we'll find one later that you can get really vibrant colors, metallic colors. You can add carbon fiber filled filament, wood filled filament. So you can bring different attributes to your build. And depending on the plastics that you use, like something like a TPU plastic has incredibly crazy good layer adhesion, but it's a little difficult to print with this technology. With the resin, these are just very messy. You're going to go through boxes and boxes of rubber gloves and paper towels and isopropyl alcohol jugs of that. So that's one thing to know, that pro and con here is when the FDM print's finished, you can pretty much pop it off the printer, and maybe you have to clean up some hairs of plastic. Maybe you don't. It depends on your print settings and how dialed in you've got the temperatures and everything. But for the most part, FDM is pretty finished if you like or don't mind the layer line look off the bed. If you don't and you want it to like look perfectly smooth and painted, you have to do some filling and painting. But you'd have to do that on resin also to get the colors that you want, right? But you wouldn't have to do the sanding step as intense. So one thing to look at with resin, everything you print in resin, for the most part, is going to have these guys here. And these are called supports. These supports hold your model in place. It will leave imperfections on the surface, depending on where you have to add them, that are going to need to be cleaned up with sanding and some kind of clear coat if you're keeping the color, or painting if you are going to airbrush or hand paint these yourself. But these prints are like almost identically strong in all directions, X, Y, and Z layers. So you have a little bit more robustness, and then depending, your materials library does give you some flexibility, maybe for a little bit easier flexible prints with certain types of resin, harder prints. You can mix some resins depending on how you do it, where you can take like a more flexible resin and like a 4K model resin, something that's meant to print fast, mix it with like 10% of the more flexible resin. And so you don't have this like super rubbery feeling toy, but or model. It'll actually give some robustness. Let's say you're making a deer with antlers. Some of the resins, even though they're very strong, the thinness of the antlers themselves would cause them to be brittle. But if you added a little bit of a more rubbery type resin, you can get some flexibility to it, so they'll give before they break. So you have a little bit of, you can do some mixing and create hybrids when it comes to this. Whereas with the FDM, you have the filament that you use, and there's no tweaking or changing the material properties. You have to decide what you want to print with, and then move on with it. So yeah, to sum that up, between resin and FDM, kind of pros and cons. Resin's messier. There's a little bit more of like initial cleanup and processing of your models than there is off of FDM. but they look a little bit nicer for the layer lines. They can print much smaller. So if you're printing N scale, it's hard to print a lot of the smaller N scale stuff on FDM, but you can print them on resin. But if you get to larger scales, FDM saves time, prints larger objects. Something like I think HO plus would be a better choice in terms of time, strength, rigidity, being able to get your model off the plate with little processing work afterwards, unless you want to paint it certain colors. But you can, if you don't mind the layer lines on there, you can do like the roof in one color, you can do the sidewalls in another color, you can do the windows in a third color, and kind of build yourself a model kit that you can super glue and pop everything in place, and no painting necessary. It will have the right colors if you have the different colors of filament. So it's a little bit of the pros and cons there.
Okay, before you go,
do we want to stop for some questions?
Yeah, there's a couple of questions here. The first one, does anybody make a resin that does not smell?
Not yet.
Not yet?
There's some water washable resins that aren't so bad. Our line of resins actually from Prusa surprisingly smell a lot less than I thought they would. I used a lot of Sarai-Tech and Elegoo resins in the past, and I can smell them while they're printing a little bit more than the Prusa Mint resins that we have. And like the Prusa Mint Tough Orange behind me, I was printing with some of that, and surprisingly it didn't smell. But that could also be I moved the printers into a slightly larger room. So I'm not sure one way or the other, but they all do have a certain smell to them. You are correct. And it is not always a wonderful thing. Some people that I know, when I've been around the country meeting with schools, engineers, businesses, some of them have them at their desk, and I don't know how they print with the resin printer right on their desk at work. But
okay, here's one on the water wash resin. Are there any downsides?
The only thing that comes to mind is that I believe the material library isn't quite. Let me go here. The material library isn't quite as robust from the water washable resins that I've seen yet. But I haven't been buying a bunch myself in terms of for what I use, because I use a lot of engineering resins, engineering grade strength and everything. So I would take a quick Google search and find out if it's gotten better in the last year or so, since I bought a few of them myself just to test them. So the only thing I can think of is they're a little more brittle. They're more for model from the ones that I had purchased previously. When they first started coming out with water washable, it was kind of that model grade, something to look at, not necessarily something to play with or post-process, or you can't work with it as well. But that may have changed. Some of these companies' libraries may be getting a little bit better material properties nowadays.
Okay, this one, you might cover this later. Is that something you're going to talk about?
Yes. So okay. I will get into creating a model a little bit.
Okay.
And we can breeze through the next part I want to talk about, just so
Alrighty.
people know kind of what's out there. Because not every FFF printer is identical. They do print very similarly, but there are some pros and cons to different types. And so after we go through that, I'll get into kind of like workflow. So
Okay.
Where do you start?
All right, here's another one. Do you know if anyone makes a clear filament? I have been using my resin printers to make these models, but I like the larger item on the filament printer.
Yes. So there are lots of clear filaments. can we be a little interactive? Does it need to be optically transparent, like a window, like you need to see through it? If he can answer back, that'll be fine. If not, I'll cover both sides of that. It's a lot harder to get the transparency for like clear, like seeing through a window on FDM, but there are people who have done a decent job at it. CNC Kitchen is a guy that talks about 3D printing on YouTube and does a lot of experiments, and he's got a wonderful one. Recently he did a cover for this printer here, so you could see the gears on the next extruder spinning, and he used FDM plastic, and he got them decently clear. You can see through them, you can see the gears, but you can still kind of see the layer lines. But if you do 100% in temperatures, like you can get something that if you added a clear coat or put some resin on it, you could get it to be clear and see through, but it won't look like a window pane if you need something that's like really clear.
Yeah, he says he needs to see through it.
Yeah, that unfortunately you probably want to do resin for that. And I know with yellowing that becomes a problem, ambering for some of the resins. So if that's the problem you're running into, two things you can try. They have UV inks. You can try and take a UV ink that's purple and mix just a hair of purple into the mixture, so it has almost a purple hue to it. Also, the way that you cure it, if you over cure, they'll start to amber. If you leave them in the sunlight will 100% amber. So if it's sitting on your kitchen table or something and the light's hitting it, they'll start to amber. When you clear coat them, I clear coat a lot of my resin prints to make them transparent with epoxy. You could also use an epoxy that has a different tint to it. So there's everything from amber, yellow, all the way through like a blue tint for epoxy. So you could try maybe one of the more blues to clear coat it. And if you're using something like from Home Depot as a clear coat, know that there's oil base and water base. The water bases aren't as yellow. The oil bases will yellow. So pick a water based clear coat if you're doing like from Minwax or something, or polyacrylic probably.
Okay, I have another one here that you'll probably answer soon. Right now, $200 will be my price range. Filament printer. Are any of the printers at the price range any good, or should I wait?
So my answer here would be that the closest printer that we have in our lineup is the Mini, and that guy's $452, and it is a workhorse. The thing that's tough is there are plenty of printers out there from Anycubit, Creality, and other various manufacturers that sell a $200 printer. They do work. They are getting better. The problems that I had, because I started off with a $200 printer, is that you don't have as many features, and some of the things matter. So if you have time to tinker with the machine to set the bed heights and to set the nozzle heights, with used to use a little piece of paper underneath the nozzle after adjusting the bed up and down. There's a lot of pre-setup, and a lot of the springs were inconsistent from the factory. And so what I sacrificed in price, I gave back more than in my own time. I did learn a lot about 3D printing going that route, because I had to fix the machines a lot. I had to do a lot of maintenance. Things would clog, jam. My extruder clip broke that holds the idler bearing that pushes my filament through the boat, and like it just cracked one day, and then the prints weren't coming out right, and it took me a few hours of test prints to like figure out what it could be and go through all the steps. So short answer is like, yes, there are options, but I think depending on what you purchase, there is a little bit of, if you buy at the like low end entry level range, you do have a lot more hands-on. You can still get a quality product out of it. Like, I'm not saying that you can't get quality prints, because you can. It just might take a little more TLC and a little more of your time. a little bit more intimate knowledge of the operating parts, so you know how to do all the alignments correctly. You may have to tram the printer yourself. You may have to do the bed alignment like really tightly. Some of the beds, they're not perfectly flat. And so even if you're using like a float glass, or you just have a magnetic bed with a steel sheet, if you take a metal ruler, I know there was one guy that I was helping, part of y'all's community. He was having trouble with that style of printer getting bed adhesion, and I had him take a straight edge that he trusts, put it across the bed, and shine a light underneath, and you would see where the high and low spots would be based on where the light would come out. And I had him shim the plate, so he used just basically painter's tape underneath just to do a test run. And sure enough, leveling it out that way, it allowed him to get prints. But if you don't take that time to shim it, you could have like high and low spots. Maybe 3/4 of your bed will print fine, but then the other 25%, you just can't quite get it right. And if you get the 25% to work, then the other side doesn't work, right? So, but they are like, as you wait over time, I'd imagine maybe 1-2 years from now, the technologies from the higher end printers filter their way down, and as time goes on, and the more affordable printers start adopting the technologies. So there's bed leveling sensors on both of these printers, where it goes and maps the bed out, and it takes so many points. You do max of 49 points on this guy here, and what it does is it makes a digital map of any high and low spots, and it moves the bed to make up for any of those spots. So the first layer is perfect, and then it starts like slowly weeding out those high and low spots until by 2 or 3 layers in, you have a perfectly flat plane for it to work on, and then your prints come out wonderfully. So
okay, last week when we were talking, you said there are kits available also at a reduced price.
So there are. So this guy is the one that has the kit, and it's about $300 less for the kit than it is for the fully built. If you do the kit, it will take about 8 to 10 hours, depending on how savvy you are. Most of that time is in reading the instructions and figuring out what goes where. If you had it all memorized, you could probably build it in 5 hours. If you didn't have to spend as much time, like, all right, so they said this goes here, and I have to tension it like this. Like, there's a bunch of processes that you'll be doing for the first time, so it takes a bit longer. I'd say schedule somewhere between 8 to 10 hours for the build. And yeah, that'll save you $300. And if it's your first time with a printer, one of the benefits to doing the kit is that you end up going through all the components in the machine, and you'll know the machine intimately. Our printers, for the most part, are pretty stable. They don't have many issues. When I'm talking with customers for troubleshooting, it is a little tough sometimes, because I've only seen so many problems, and I have 8 of these printers. Well, 10 now after joining Prusa, of this like specific style of printer here. And they don't fail that much. So you'll get to know what everything is, and if there are failures or small failures, sometimes nozzles get clogged depending on the filament you use, the type of filament. You want to have a good blend of like the right components, a hardened steel nozzle for a carbon fiber filament, things like that can cause problems. But that's a lot of those things that happen with me were user error, not the machine's fault. But yeah, the kit, it's $7.99, and that one, if you build it, it ends up being a good way to understand like what each component is, especially when you're looking in the slicer software, like we asked about before, when I was showing the printer, and we asked, XYZ, things like that. Like, you'll understand kind of how it functions and what part is moving. So if you don't know what an extruder is, if you don't know what a hot end is, if you don't know what a heat break is, right? You're going to learn what all these things are through the process of building the kit. But if you don't have time for that, for $1,099, they fully build the printer for you. They test it, they ship it, they give you a printout that everything was tested and functional before it left the factory. And then you basically just plug it in and get to printing.
All right, here's another. I know some have recommended heated printer beds. Does the printer have a heated printer bed? The one that you were talking about earlier.
Yeah, for sure. Most printers these days have heated beds, and the reason being is that your layer adhesion isn't so good with almost any plastic on a cold bed. So different plastics have different temperatures that they like to bond to the plate to. It has to do with the melting point and glass transition of these printers to what makes it soften, what makes it melt, and then that's, if it's not soft enough, if you run the temperature too low to get to the melting point, it will melt, but it'll be a little more firm than you expect, so it won't stick to the bed because it's not fully melted. So having the heated bed and the right temperatures in your settings is what will allow you to get good layer adhesion on that first layer. And for the most part with these printers, the FDM is that first layer adhesion is of utmost importance. You get a good first layer, then you're off to a great start with a successful print.
All right, I know you'll probably cover this soon. Are there downloadable and shareable files to print items from?
Yes, 100%. We have a website that I'll show briefly, printables.com. And on Printables, it's just a repository or database of things that people have made. And actually, I'll just go ahead here. So here on Printables, I typed in N-scale, and you can see on here there's a repository that just has some models that people have shared. It says the license types on here, so that's good. If you want to do it for your layout and print it for yourself, everything is, for the most part, free. Everything was free, but some of our creators have been doing such a good work in creating so many files for the community. We've given an option for them to create clubs with exclusive files that people can donate or purchase, but for the most part, everything you find on Printables is free. And if you take a look, you'll just have to type in a couple things you're interested in. These are N-scale specific, so I imagine these are 2-scale. And but that doesn't mean you can't find a specific landmark or something that you want to have in your layout, get it at a different size, and then just scale it down to the proper size and print it for your layout. But you can see some people, do some good work modeling. They spend a lot of time on these. And our community is pretty robust. We also run competitions. So with these contests, one I would like to do at some point is talk with them about potentially doing a model railroading contest and getting some of the creators to work on or build models for model railroading. Uh-oh.
Okay, here's another
I think
one.
my internet's acting funny.
Okay. Can we see your 3D prints?
Like mine specifically?
Yeah.
Yeah. Like things that I've made that are already printed. I might
Yes.
have to go grab them from another
Okay.
room if we can
Well, we can
take
do
a break
that,
and you guys
later.
can chat. Okay.
Okay.
Yes,
Here's
let's
another
do
one.
that later.
What about ABS filament?
ABS is wonderful for things that need to be outside, things that need good impact strength. It is a little stinky. Like when printing with it, it does have a familiar smell that you'll get used to. It is higher temps, but most of the machines today can handle those temperatures. And so actually I think every machine these days on the market can deal with it. So it is a little more prone to warping than, let's say, PLA. So for most modeling, because, I know kids at these shows do like to touch things even though you ask them not to. But for the most part, if these are meant to be seen and not touched or played with, PLA is probably going to be your best bet, just because it's the easiest to print with. It's the least warping. It's the lowest temperature. And the models, there's less to design around because it's just an easy flow. But it also doesn't have the best material properties. So if you're doing something functional or something for outside, right, ABS is wonderful because it has better impact strength. It's UV stable, so it doesn't get brittle from the sunlight. So things like that. And that's where learning the different material types and plastics will help in your design. And if it's just for your layouts, I think PLA is probably the easiest material to work with. So I would strongly suggest working with PLA, but it'll print ABS if you have ABS or you like ABS, you're fond of it. I've just noticed the bigger the model gets, the ABS tends to warp easier, and so we actually have an ABS blend that's not doesn't warp quite as much as just the regular ABS. And from a cost perspective, ABS a lot of the time is cheaper. It can be one of the cheaper filaments because it's a more industrial ready plastic. There's lower price on the plastic pellets on the market, so they can make it a little cheaper. So all things to consider, because there's definitely some boutique plastics out there that people make all kinds of crazy stuff, like let's put bacon in filament so that way when you're printing it smells like breakfast. Like there's some fun stuff out there. So who knows, maybe if somebody's got a diner, you want to print it with some kind of bacon infused filament so people can start smelling the layouts.
All right, here's one. Is it best to use the same brand filament and resin for the printer?
That's
I'm assuming this thing
question.
for the brand of printer that you have, use the same brand filament and resin.
So I don't think okay. This is going to be a good thing to mention, and I don't know that I necessarily had it on my list. The brand of printer and the filament aren't necessarily. You don't have to use like Prusa mint with a Prusa printer. We would love you to, and the reason why I would suggest that you use Prusa is that we have one of the tightest tolerances, if not the tightest tolerance. I don't want to misspeak and say it's the number one, but it's up there for sure. And when you're thinking about the way that the plastic comes out of the nozzle, if the plastic is thinner and thicker, that's going to show up in your print. And so some of the Amazon Basics type, cheaper filaments, they can, again, everything's getting better over time, but they can have a little bit more inconsistency in the thickness, which leads to some artifacts in your prints that aren't ideal. So what I would say is if you have multiple printers or you're printing with different colors, I would stick to the same brand of filament to print your model if you're doing multiple pieces. So like if you have blue, red, white, and you want to print something with those colors, use the same filament and you should be able to expect similar results because the manufacturing process is identical across, hopefully, right, across their manufacturing line. So you'll get a very similar looking print for each piece. So if I want to make a foundation for a house, or like let's say there's a house in the mountains, so I print like a rockscape out of some kind of marble, and then I'm printing a house that goes on top of that, and then I need a roof and a chimney, and I'm using different colors for all those things. Like if I start with Prusa mint, I want to continue with Prusa mint. And the other thing about our filaments is that we have a QR code on here. I don't know if you can get that guy. But basically, if you take this filament and you scan this, I'm backwards, not backwards. If you scan this QR code here, it can show you like the consistency of your filament, and we guarantee our spools within 2 microns, I believe it is. And so it's a very tight tolerance for what we're doing here. Is it 2 or 20 now? Now I'm wondering if I misled you. It doesn't say on here. That's something I should know off the top of my head. But it is the tightest, whatever it is. If it's 2 for ours, it's 5 for a lot of other brands, and if it's 20, then it's 50 for a lot of the other brands. So we're usually like half of whatever their plus or minus spec is.
Okay, going back to the printables, do these files work with resin printers as well?
Yes. So across all the printers, you have STLs. You can use OBJs. 3MFs are starting to get popular in slicers. But this is maybe a good segue to come into the Prusa slicer. Oh, I've got to share the Prusa slicer screen. Let's see. I think on this one I have to end my sharing, and I think I hit it. Here we go. Setting. Well, okay, give me 1 sec. So we look at this guy. If I go to export this, right, it gives me a couple different files here that I can export.
Mm-hmm.
So I have a OBJ object file or STL stereolithography file. And when I pull this file out, then I'm going to import it into my slicer software. And then that's going to allow me, see if we have it in here. All right, I'm getting way ahead with this one. I should have stayed. Should have stayed it.
Yeah, we got a bunch of.
We're jumping around.
We got a bunch of questions here.
Yeah, so I can pull this model into the slicer, right? And then the slicer breaks down the different layers and how the nozzle's going to travel. Whether it's with resin or with FDM, basically what you get is a bunch of 2D slices that stack on top of each other. So if you can see in here where you have like the 3D printed layer lines, if you notice, this hole isn't perfectly round. Now that's because of the way that they have it oriented. And you can see here, it says print a circular hole printed vertically. It shows you that like there's a little bit missing right here, right? It's a little flat. So, but if you print it horizontally, you can get perfectly round circles. So I mentioned that because the slicer is going to tell the machine how it needs to behave to get your 2D layers. So you can see on here the 2D layers. If this was a tighter resolution, like a really thin print, I think this was printed thicker layers to illustrate the point, right? You have control over this in the slicer software. So you can see the way it's printed. The preview shows you all these 2D. So it's going to print each slice right on top of the next, but it doesn't really have the resolution to make that whole perfect. So when you bring your STL in, the STL file, whether it's for an FDM, it's going to tell it like how to do each one of these layers. But then with resin, it's the same thing. It's going to tell it how to do these layers. So you'll still kind of get something like this with resin even. It just, the layers are so much thinner that these straight lines, there's more of them to stack, so it looks more round. But the slicer will control the difference, like how the travel paths of the nozzle go. So for the FFF printers or FDM printers, it'll tell it how to move and travel to fill in all these gaps. But then when it comes to the resin prints, it'll do the same thing, but it'll mask the light. So if you think of a resin print, this whole thing would be one solid object, no lines, right? It's not drawing each one of these extrusions like the FDM is. And this would just be one solid piece. And so they'll use the same type of file, right? The model itself. It just, the slicer will distinguish how to bring that file to life with the type of machine that you're using. That makes sense. And
Okay.
sorry, I most of my answers aren't just yes or no.
Okay.
I apologize.
Okay. What do you think about PLA Plus?
I think with PLA Plus, it's unfortunate that some of the vendors are using it a little gimmicky. What I would say is for PLA Plus, the thing you want to look into is, does it have some kind of annealing factor to it? Does the provider or the manufacturer provide steps for you to take your model and, let's say, bake it at a certain heat in order to further strengthen the material characteristics of the PLA? I have seen kind of for and against it. So I believe there is a world where PLA Plus is a thing, but I also think there's a lot of manufacturers that just PLA Plus became the new, like, oh, if it's better than PLA, I've got to buy it. And so they started like adding things that don't necessarily make the plastic any better than regular PLA, but they brand it as PLA Plus because they added something to it. But some of the guys on YouTube you can look that do the materials testing, you can find brands that actually do test better than traditional PLA in terms of, impact strength, layer adhesion, things like that. So CNC Kitchen is a good one of those. A guy, Thomas Sandlotterer, I believe he also does some tests in some of his videos, but they also do a ton of videos. CNC Kitchen is mostly testing. And it's a wonderful resource for someone just learning like material properties and how to choose what to work with. But I'd say regular PLA is probably good enough. PLA Plus, do your homework and you can find some good PLA out there.
Okay. How often will the Prusa printer need to be leveled compared to others on the market?
Just on the initial setup. So it walks you through a calibration wizard where you do your bed leveling. And so when you first set up the printer, it'll walk you through like basically how to set the first layer. So the thing with the bed, there's not actually anything on here or under here to play with to make the bed level. It's manufactured with a nice robust plate underneath that you bolt it to, and you put the magnetic sheet on top of it, and the plate is flat enough that the tramming or the leveling, it's not the tramming specific, the leveling of the feet of the printer is what most important. So when you're tightening, I'm gonna have to look at it, do this. When you're tightening these screws here, you can get just a little bit of play, and so there's like a tolerance stacking. So if I tighten this side a little bit off, and then the other corner like across from it is also off in the same direction, I might get a little bit of something that's askew, and that's just things that you need to pay close attention to. It's in the instructions to make sure it's not. And you can loosen them all, press it down on a flat surface, and then retighten it, and it's perfectly fine. But it's all within tolerance of the sensor, the Pinda sensor, or Super Pinda now. Actually, this guy, I'm talking about the older printer. This guy does the bed leveling with touch. So it actually comes down and the nozzle touches the plate physically, and it has a load cell. and the load cell takes measurements across all the points. So it will level itself is the answer I'm trying to get to. As long as you've built the frame and it's not askew within a certain tolerance, but the software will actually tell you. I think of the 8 that I built, one of them was slightly off, and I got that alert, and it didn't feel that wobbly on my table. Like it didn't feel that far off. And so when it checked, it told me like, hey, this is outside of the tolerance of the sensor that you're using, and it needs to be changed. So I just loosened all the bolts, found a better place on the table to press down and flatten it. Because we have like a leaf in the table. So I think I had it like one half was on the leaf and one half was on the other side, rather than putting them both on the center on the same piece of wood. Once I did that, the sensor goes through, levels it all, and then after it levels itself, you do a first layer calibration. And so on the first layer calibration, this is one of the things you have to kind of get an eye for, and there are pictures online to help you. But basically, you're setting how far away you want the nozzle to be from the print bed. And depending on the gap, you'll either, if it's too far away, the plastic strings are too thin, they don't squish and adhere to one another sideways. So what you have are these layers that are a little bit separate. Let's get in front of the camera. That are a little bit separate if it's too high, but then if it's too close to the bed, they overlap too much. And when they overlap too much, you actually start to get like it does this on top of itself. So like it starts to stack plastic on top, and that's not good either. So if you get a perfect layer, first layer, it's like side by side wonderfully. And once that's set, there's some of my printers I haven't touched that setting again for a long time, unless I physically do something to the printer or change out my sheet if I want to go to a different build plate surface, like a smooth plate versus a textured plate. Yeah, these things have been, I moved to all of these, and then eventually took an opportunity with the company because like I've been using their printers and they've been good to me, and I've had the least amount of headaches. I mean, I have 4 or 5 other brands of printers out there, and I don't know, the good old black and oranges give me the least amount of headaches of the printers that I own. So
Here's another one. Is Prusa filament made in China?
No. It is made overseas. It's not made in China. It's the Czech Republic. So the company Prusa is in the Czech Republic. It's in Prague. I got a chance to see the factory. There is some YouTube videos on our channel. There's 2 that are really neat if you guys are just curious and you want to watch like a documentary style. One of them is like the history of Prusa, like how it started, like the first revisions of the printer that the owners and founders ever made, and then like where it is today. And it's like the road to 1,000. I'm trying to think of how many printers are in the factory. I don't think it's, let me see if I can find the video, but it's a good video, and we'll put it, I'll give a link to Tom, and but basically it it is 100,000. Okay, the road to 100,000 original Prusa printers, and then it shows like
Your audio is breaking up a little bit now.
let me. Okay.
Okay, it's back. It's back again.
Okay. So
whatever you doing, your audio went out.
I know what it is. If I pull up YouTube, it messes with it apparently.
Okay.
So it's a road to 100,000 printers, and if you watch this kind of a documentary of how we started and where we went, but it gives you an idea of the tour. A lot of the 3D printing YouTubers have been doing tours of the space, so it can kind of show you a bit about how the filaments made, how the printers are made. And one of the things they spend a lot of time quality testing the machines, the components, the filament. They're very good about the color control. So the cool thing, the polymers team, they spend a lot of time making sure that the way that they keep track of the colors, they want a roll of filament 2 years from now to be the exact same color as it was the first time you ever bought it. And so I think that kind of dedication to like consistency is undervalued. It's very easy to be like, oh, well, this roll of filament's $18 on Amazon. I'm just gonna buy it, save some money. But I started off like my little journey to getting to the right plastic is like I bought everything under the sun I could find on Amazon. All the cheap stuff, some of the expensive stuff. I was just curious. And what I found out, and kind of the reason I wanted to make the point earlier, is that even though they're the same name, right? It's PLA or it's PETG, it's these different plastics or the same plastic from different vendors. I was having to start changing my print settings to avoid, like, one PLA would print perfectly fine and then two other vendors would print with stringing. So I'd have to lower the temperature to get those ones to print fine, but then the other one would under extrude a little bit, or like it'd be a little brittle. And that's where now it's like if you find a filament manufacturer that you just like, it's whatever settings you want to use, or you can find some good settings and dial it in. I think in terms of like if you're printing regularly, you should just keep using the same brand, because it helps bring the consistency into your world where you can use the same settings and you already know in your head or you already have a process written out that works. And so you don't have to spend as much time kind of tinkering or toying with the settings, right? So that's kind of what I was trying to illustrate earlier when I was saying using the same brand of filament from the same manufacturer, because it really does save you some time in the long run in terms of like, once you figure it out, you kind of know what you're working with. And from batch to batch, there's not a whole lot of variability, but from one manufacturer to another manufacturer, there could be a lot of variability. So just something to think about there.
Okay, a few more questions before we go. What's the warranty on the $450 model?
I believe it's a 2-year warranty. These are good questions for the I'm sorry. I believe it is 2 years, but let me make sure I'm not lying to you. And this is something we can take a look at on the website. Let's see, original mini. But here's the thing. So even, okay, this will allow me to actually talk about something though. So even though the warranty, right, there's an end of the warranty that protects you from manufacturing defects. For the most part, like Prusa is going to make it right. If something isn't good from the manufacturer, like they're going to send you parts and correct it. But beyond the warranty, if you have some issues, we have a 24-hour support, and they are always there to answer questions. They've taken questions that aren't even about like our company, but they're just willing to chat with you about what's going on. If you need troubleshooting help, if you need parts, the parts, there's a whole bunch of spare parts that are easy to access, and you have help along the way to help you fix it. And that's one thing that like you don't see other companies really advertising, and I guess it's not sexy, right? So we have kind of a holistic approach. So we want to, like, getting heavy into printables right now, we want to bring ease of access for people that don't model for a living or aren't interested in learning how to model. And so you have to get the printer, we want a place to get models. If it's easy to get models that help you have things to print regularly, we provide the polymers. So we have very tight tolerance filaments that we create for you to use that print wonderful models. And you have the support, 24-hour support, working with the team. But also, because we're open source, like you can use other brands of filaments. You can do upgrades and mods with some of our partners or other companies that sell wonderful aftermarket. If you're the type that wants to soup up the printer, within the community itself is so robust because it's open source, right? You get a lot of people that have done their own things to the printers themselves, and there's a lot of information on the forums from the community knowledge that's out there. So,
Your audio is loud, but it's breaking up a bit.
yeah, I'm sorry about that.
Okay, there you go. You're back on again.
Okay, maybe it's an internet thing. I promise the connection I'm using is fiber, so I don't know, but it's I don't know.
That's okay. Okay. There's a few more questions here.
Okay.
Okay. Are slicer SW specific to a printer manufacturer?
Not specifically. So it depends. Some of them are. Ours is an open source, and we have a lot of different printer profiles from other manufacturers in our slicer. So the slicer too is free. You could go download it today and play with it if you just wanted to see what it was about. See if your profiles exist in there. There's even a way to create custom profiles, so that way if you have a printer that nobody's ever heard of, but you know how big it is, the components that are on it, whether it's one extruder or dual extruders or whatever it may be, you can build a profile to use your printer on our software. And it's been getting so much better. The last few updates that they've had, you can customize and like do text right to the model in the slicer rather than modeling it. So if you don't know how to do this yourself, you don't need to go and do modeling software and learn how to do it. You can do it in the slicer. Supports, they've been making it easier for the support removal. So it leaves less defects, but it's also easier to remove while not creating any problems with supporting your part. You can paint models to do multicolor. The one thing that I didn't mention, so if you do the mini right now doesn't have multicolor capability, but you can do an add-on for this one to get 5-color capability on this guy with the MMU3 that we've released. And so that one's been super robust. If you see anything about the MMU2, there were some headaches initially with it. So there's some stuff out there that the MMU2, the way it shaped the tip, it would have feeding issues. I've had some problems myself with it. But again, a lot of the problems were me not doing maintenance or things that I needed to do regularly, scheduled preventative maintenance, led to it not being as good. But the MMU3, they really took their time. They delayed it a bit, but like it's been so robust. All the conferences I've been to, it prints, and it just prints what I think I was at Form Next for 4 days, and they had it running the whole time, didn't jam once, and they were just chugging out sample prints. They were doing like the ducks for the Jeep. If you've ever seen the Jeep thing where you got ducks all on the dashboard for the Jeep, I think they were printing a bunch of those just by the build plate full for the whole conference. So, but for the slicer itself, all this stuff, if you have the multicolor and you can, paint it, you can do all kinds of neat stuff in the slicers now. And since it's open source, you can use just about any printer with it. Just if the predefined settings are not in there already, you might have to do it yourself, which would take a little bit of digging or community help to get the proper settings if your printer's not already listed. But there is a big library of the most popular printers in our slicer is already, so should have you covered there.
All right, here's another one. What is the build size of the Prusa Mini, and would you recommend using a flex plate with it?
Yeah, so the Mini is a 7 by 7 by 7 inches. So if you think of whatever you could fit into a 7-inch cube, you can fit on the Prusa Mini. And then in terms of the MK4, it's 9.75, I think, by 8.5 by 8.5, something like that. So it's a little rectangular-ish on the build plate. But you can fit. You wouldn't think the 1.5 to 2 3/4 inch would make a huge difference, but surprisingly, especially on the diagonal, what you can fit is actually quite different depending on how large it is. I make some custom plates for a customer of mine, and they're narrow, but I can fit like the largest plates that we make just barely from corner to corner on the MK3S and the MK4, but I could never fit it on the Mini. And then as far as the flex plates, I don't use anything else. I have a scar on my thumb here where I was using a glass plate on one of my other printers, and I was having just the hardest time getting it to come off. And so I was using like a spatula scraper, and it had a sharpened edge so it can get under the print easier without damaging the first few layers. And it was like not going, and then it just popped off. And I even had my hand like down and under the print bed, and somehow like the way it slipped, it just caught my thumb and sliced my thumb open. So at that point I was like, never again. I went and got some flex plates, and now if you want to take something off of these guys, you can just take it and bend it and they pop right off. So for the most part, you flex it a couple times this way, flex it a couple times that way, and usually whatever you have pops right off the surface.
Okay, that was all the questions up there for right now. So if you want to, you can get back to your presentation.
Okay, so we'll go kind of just quickly through, I guess, start to finish. Let me take a look right here. If you have anything you want to chat with the guys real quick or try to pull up, I hid the your screen is being shared button, and so now in order to get rid of my window, I need to find that button.
Okay.
So, sorry about that.
Okay, while you're figuring that out, I'm going to say thank you to everybody, and that'll take about 2 minutes. So that'll give you enough time, I hope. You can now support me on my locals community, Tom's Train of Thought. Membership is free, and by clicking the join button, you can support me for as little as $5 per month. Link is in the description and in the chat. Thank you for your contributions during the live stream. I really appreciate it. I would also like to thank all the moderators who have helped me out in the past years. Thank you very much. All right, thank you very much for your support. And let's get back over here, and it looks like Logan is still on the same page right there, so I'm not sure what's going on. He's having trouble getting up.
Are you here? I've got it. So
Okay, you got it? All right.
yeah. Let's see.
Well, we got one more question in here.
All right.
Okay. Slicing using a skirt versus brim. Have a model that printed using a skirt. The next print came on the build plate. Put brim on it. Then it prints. Okay.
Okay. So okay, so basically it sounds like maybe he had a model that was warping with a skirt, but then he used a brim and it didn't warp. Maybe is what we're getting there. If you want to verify with him that's what he means specifically, that can happen. And so let me see. Now that you guys can see my screen, I can actually try and pull a couple things in here.
Yeah, Thomas, if you could elaborate on that. Okay, there you go.
So one thing you could do, if you know specifically like what you're having the issue with, the brim goes all around the model, right? So what he's saying is if he does a brim, it will go all around, right? It's going to go all around the outside, and then you have to pull that brim off, and it's going to leave kind of a discolored, like if you're black is the easiest one, right? If you're using like a matte black to print this, what it'll do is it'll leave like a white, like stress on the plastic once you've peeled it off. Now, one thing you can do to make that go away, heat guns. Heat guns for 3D printing are like wonderful, or torches. If you can heat the plastic up a little bit, the ABS will, or whatever plastic you're using, if it's black, it will regain its color after you've melted it. But another thing you can do instead of a brim, let's say he used a brim and it's for these corners, right? You can do something called mouse ears. And if you make this like really thin, and then you move it. So you put this guy down on the corner, right? Whatever you're having trouble with, you can do something like this, and it'll have all the surface area that acts as a brim just for this one corner. So you don't have to worry about peeling the brim off anywhere else here. And so even if you had the skirt, you could still do this, and then it will end up giving him that brim effect on the trouble area. So sometimes you can learn little tricks like that in terms of helping like prints that are stubborn and want to warp do to stick, not end up coming off the build plate or getting ruined. So if that's what he was talking about, the brim, if it solves your problem, you want to use it, and then you adopt or adapt post-processing to help fix maybe whatever you didn't like about pulling the brim off, like discoloration. Like I said, heat gun or a little mini lighter torch. You brush that really quickly, like back and forth, left and right over the discolored area, and it should regain its color back. Otherwise, you learn other little techniques to kind of just shore up the part that's struggling. And then one last thing you could do if you're having trouble with your prints is, let me see if I can get back here, spray adhesive. So something like this, I know some people use like magic glue or glue stick, but I found this company 3D Lac, and I use their products, and it adheres really well. I even used like hairspray when I first started doing it, because that's what people on the internets were saying, and you got to be careful what people say on the internet sometimes. Hairspray did work, but I did a bunch of tests, right? Because it's just how I am, right? So I had glue stick, hairspray, 3D Lac, and there was one more adhesive, and this one just leaves the least amount of residue. So like the hairspray was building up and starting to get real sticky, and like it was, the alcohol was thinning it and then moving it around, and like when I touched it, it was actually getting sticky. This stuff adheres better than the hairspray did, and the residue is like dry to the touch. It's not as sticky, and it's easy to wipe away. Like if I want to really do a good wipe down, usually I can spray it with that stuff and do like 3 to 5 prints with only a little bit of alcohol and like a quick, like, because basically the alcohol will reactivate it and I can thin it back over the spot. So if I'm printing the same thing 5 times, I can usually go off of one coating with that, and it'll help. And it's been a wonderful product. So things like that, like there's all kinds of tools to 3D print. Like you have to get creative. One of the things I tell people is like, if you can't do something with 3D printing, a lot of the time it's you're not opening your mind maybe enough, like, to the creativity and thinking outside the box. You might not get to the 100% solution that you want, but there are ways to like get around almost anything if you spend enough time thinking outside the box, and then you have little tricks for the future of how to do some of these things. So, but all right.
Russ's Rocco Railroad said, "I've learned more tonight about 3D printers than any other time."
Oh, that's awesome. I appreciate that. Thank you. So, okay, cool. I'm going to go to, all right, so let's just talk real quickly because we are starting to get a little long here. Sorry, guys. I'll just talk about like where to start importing models. So, okay, you buy your printer, right? So you pick up a printer, you take it home, you plug it in. This is assuming you didn't buy the kit. If you buy the kit, then you need to spend a day building it. And for those of you that like to tinker, or those of you that want to know more about just how the printer works and the parts, like the kit it's a good way to save money and increase your knowledge. If you don't have time for that though, and you have a busy job, or you just don't want to fiddle with it, like $300 sounds like a lot, but my buddy used to tell me all the time, buy once, cry once. And I'm so notorious for buying. I start at the bottom and I buy a bunch of the cheap stuff, and I try to see what's good and how to work with it. And then after about a year or so, I get tired of like finding workarounds. So then I buy like the mid tier. And then eventually when I do my homework enough, and I've been in the industry 2-3 years now, I buy the stuff that everyone said to buy in the first place that I thought was too expensive. I wasted a couple $1,000s just getting to the, okay, they were right kind of thing.
That's how it usually works.
Yeah. So what I would say is mainly the big thing that we have that I think is invaluable is the community and the resources. You know, we have academies, we have forums with vibrant community, we have printables with just the creators that I've met. I've been going to these different 3D printing conferences, and I've been meeting some of our top creators, and they're just wonderful people that love making models. Like, there's a lot of enthusiasts around our brand that build a community that's wonderful to be a part of. So that's something, if that's, again, it's intangible, it's, you know, hard to put a value on, but, you know, there's a lot of wonderful people willing to help. So you buy your printer, you take it home, you plug it in, and it's time to print. What do? Well, you have to either come onto printables and then pull up, you know, a model and see if the contest page works this time. Here we go. So of course for the holidays, this one makes sense, right? Decorations, you have jointed figures. So they'll do these different, they did jewelry. So you can come into here and find something that maybe, right, piggy banks for your cars, or, right, they did a defrosting one. If we had enough people and we do some of these chats, I'm going to try to go to some of the model railroad shows and, you know, just show you guys things that I've made, and think, like, just so you can hold and touch and see what it looks like. If we could get enough people, I think, interested, I think we could get a contest going for model railroading. So you could have like an N scale contest, an HO contest, like whatever, or maybe a specific model railroading, and then what's a specific thing that's hot that maybe the market doesn't have right now. So these are the kind of things that we can do here at Prusa, and I think it would be wonderful to get your community one of these contests, because that would open up the library, right? So if we did an N scale thing, I think there was only like 70 or 80 N scale things that came up under just N scale. But if we did an N scale competition, that could be 300, 400 by the end of the competition models that are added right to the repository. So, but basically you bring your printer home, you come here, you find a model, you say, hey, okay, I want to print this thing. I like this ornament. And when you go to download this one, you might have to sort through. Each creator does things their own way. So normal tolerance version of this card, I've never printed this file, so we're finding this out together. But you can pull this up, and all of the things on here are okay for your personal use. It's just if you find something that you think people might like, don't go selling these creators models that you've printed without their permission. But basically you can get a card like this, and then you download that model. And once you have the model downloaded, you can open it up in your slicer. And then the other way is you can create the model yourself. So with this one, I just took an SVG file and made a Coca-Cola label, drink Coke, and with Tinkercad. So the one thing I did want to show you guys is this is super basic. We'll have to get into it another time if you guys want like a how-to Tinkercad thing. But for the most part, just to make this super simple, right? Tinkercad's like playing with Legos. All right, I'm sure this group, I think Legos were around in your guys' youth at some point even. Would I be mistaken saying that, Tom?
Yeah.
So you guys haven't played with Legos, or you have?
Oh, we have. I have. There's.
Yeah.
I think there's quite a few that have.
Yeah. So if you think about this, just like Legos, right? These are Lego pieces. Okay. Let me go ahead and turn that to this. So basically, you can see I have a rectangle here and a rectangle here, and one of these is called a hole. So whatever is see-through, when I combine it with a solid object, it removes that material, it cuts it out, right? Or, like Legos, if I take another brick, right, and I want to put it here, stretch that out, a little bit of centering stuff, right, get this thing centered, and then you can group that together, and then now you got a little garage going on, right? Now, obviously, you can make this wonderful, and you can cut out holes for windows and do all kinds of stuff, right? But basically, again, if you think about it like Legos, it's just you can remove. So this is how I would pull Legos off, right? So I want this to be a big window in the side, and then get these things aligned. Right. Then I can use the hole to remove that. All right, that wall is a little thicker than I thought. Oh, I got an idea, actually. So if you go to Tinkercad, right, this is kind of the first way to get involved in modeling. And so you can, add a little window, and you can put things in between. You can have the roof. It can be separate, right? You can just play with this and come up with your own creative thing. And it's honestly, you play with it enough, and you find out that you can make neat things. And it's really not that hard if you spend some time, again, thinking about it almost like a kid again. And, what would I do if I were you guys had the good Legos, right? Where it wasn't already pre-made and you're just putting a kit together, right? You had to use your imagination. So it was one of those ones that like you take all the parts and you can make something and depending on what you want to create, right? Like, little pencil eraser or something. So you can rotate these objects and add them on. This is not the scale, and I know you guys are scale people. So see if we can fix that real quick. But I would encourage you guys to get into a software like this and just don't grab the wrong things. But play around, right? Like just be inquisitive. You know, what does each component do? And there are videos online that'll like show you like what you can do in terms of using this software to create whatever you want. And so this is where I'm saying, like, if you want something that doesn't exist, because I've heard that your vendors don't always have the like everything that everybody wants, right? They can't be everything to everybody.
Yeah, that's correct.
And yeah, so you know, you could do something like this, make sure these things are all aligned.
So the program you're using, is that Tinkercad?
This is Tinkercad.
Oh, okay.
And so let me do a shift. Let's make this guy smaller. But oh, that wasn't supposed to happen. Okay. So, you know, now we can have, like, again, this is nothing magnificent, right? But just to give you guys a quick idea of, like, if you play with the thing. So this sign didn't take much longer than these things took to make, right? Uh-huh. Importing an SVG is pretty simple. You make the file yourself with something like Inkscape. If you can find SVGs that are, like, royalty-free, but again, if it's for your own layout, I don't honestly think it matters. You might want to look into it. I just wouldn't sell anything. If I was like this Coke thing, I would never sell this to anybody. I did this just because it's a real brand, and I knew when I came to the show, like, it's just an example. It's not even the best. It doesn't look. It's like from memory. What I've seen some of the older billboards, like old school billboards. But like you can use a software like this to create some things. Oh, okay. Yeah, sure. Okay, hold on. Yeah. I gotta zoom in though first. Hold on. Sorry. Yeah, we'll get there.
Got a long way to go.
Hold on. I know. Oh, don't worry. On Tom Trains,
yes, Andy.
That's the short answer. So, okay.
He's going to take you all the way there.
So, I don't know. Does that look close enough?
There's 1/60th.
There's a pencil. I don't know. So, now I'm never going to remember that that's there.
Okay, so if you had something that was, you know, the actual size, and you wanted to bring it down to like 1/87th or 1/60th, is there a scale in Tinkercad that you could do that, or do you just have to calculate?
Not that I know of. I calculate it. There may be something that a Tinkercad Pro knows that I don't. But for the most part, what I end up doing is I do the math, and then I take a look here millimeters wise, like what it is. Then I go to, all right, what are the approximate sizes? Like I'm sure you all have done in real life of the average of what these are. And then I just convert the millimeters until it's 1/60th. And then I would then print it at that size. So like with the drink Coke one, so where I was getting at here is you either make a file or you find a file and then you export or download. And then after you get the file, you pull it into, well, you come into your slicer, and then you can add, and slicers are pretty similar, but you can tell it, hey, the sign example, grab that, and then it pulls it into the file. Now, one thing that is cool, so I mentioned multicolor, right? So there's stuff out there. There's certain ways to do this, but if you wanted to do this multicolor, if I slice this guy, what I can do is tell it at different layer heights. So let's say I want the billboard to be like a let's say a wooden frame all the way around. I can tell it right here that I want to add a layer change, and then what it's going to do is create a chance for me to change the plastic out, right? So this color, actually I should have went up one more maybe. Let's go one more. So right here, you can see the orange, right? That's going to be whatever color plastic I want to put in there. And so I'm going to put a brown plastic in first, and then it's going to pause and start yelling at me. So start beeping and say, hey, yeah, it's ready for the material swap. And then let's say this next one, I want it to be white on the background. And then only the last few layers, so I'll do that's white, and then the last few layers I'll do a third color. And so what you'll have here is the chance to do brown, white, and then like a red logo or whatever the colors you want to choose for your sign are. And you can do multicolor stacked prints. The only thing that you might not like is if you look on the side here, the side profile is also, right, 3 colors. But from the top view, it'll be the 3 colors that right, you'll see 3 colors. What I would do in this case, if I have one printer and I don't want to spend extra for a multi-material unit add-on or another printer that comes with a multi-material unit add-on, right? You can do this in 3 colors, and then you can just model a little edge banding kind of thing, right? That you can glue around the outside of this or slide right over the top of it. So if I'm in Tinkercad here, and I want to create some sort of inset frame for that, you could just bring this here, and we'll do a quick thing here. Center them up, and then you would do the measurements to scale, right? You'd want to do this to scale, so that way it matches. Maybe, have a lip. Let's drop that down there. So if I do this guy, I'm going to have a lip now. And then so I just want to show you guys a little bit of this so you can start playing. Tinkercad is a free program. That's the other thing I don't know if I mentioned. But if you use Tinkercad, you can start creating your own stuff right away, straight away.
Okay, I have a question for
Sure.
those of us that don't know anything about it. Once you make that design, okay, how do you create the file? What kind of file, and how do you get it into your printer?
All right, so that's, good questions. So that's where I'll go right after this, since we're
Okay.
making this new thing, right? So what I'll do is I'll get this guy to line up, and I'm going to do this real sloppy right now, but just to get the idea. So I'll get it to line up so it's about the same size. And basically what I'm going to do is, let's do that there. And I need to cut something out right at the bottom here. So that way it will fit around these legs. And so now, here's what the final little cover will look like, right? Get this pencil out of the way. So I can make this guy black. And actually, you'll see it better. I like using this teal color because you can see all the lines, right, that were cut into there. But basically, you would print it like this because it needs to stick to the bed plate, and then it'll stack layers up, right? And when you get the layers that stack on top of each other, this would print really easy because it's a really simple shape. But ideally, in practice, it's going to be a cover that we'll put over the billboard and drop it down. And so what you'll do is you'll do a small offset. So like with this one, you can see here now, this is like a cover that would cover any of this stuff that I showed you. You see how there's going to be 3 different color layers here. That would basically give you a way to hide that. And then you can change this border to be whatever color you want. And you just have to know, if I try to print it like this, it won't print, right? Because these things that are hanging, these lips, they try to print over thin air. You'd have to use supports. It's not ideal. But so you would just have to print it this way, even though you know you're going to use it the other way. But once I've created it, I have to know what it needs to be. So if I was doing this for real, I would take this at 75 millimeters, and I would probably do this one to the inside diameter would be 75.4. So I have like 0.2 millimeters on each side of like of a gap. So I can glue it if I want to, but a lot of the time it'll press fit and almost friction fit if you have like a 0.3 to 0.4 millimeter. But once I've got it all designed up and I know like this is going to fit on here, and again, you can kind of verify, right? Like I was showing you, let's do it this way. Like here, right? You can kind of test fit it and you can make it clear and take a look like, does it touch the walls? All right, it touches the walls, so I need to stretch it out or whatever you need to do, right? So you can kind of see through and see how it fits or doesn't fit. And then when I'm confident, and I usually make duplicates. That's one thing. If you're going to do this, if you're real close to your design, you make a duplicate and hide it over here. So if you screw this thing up and your window closes and you can't undo it, you always have the master, right? So if you guys start doing this, make sure to make a habit of making master copies, play with the duplicate, and then if you mess it up, you always have your work still here to go back and start over again, and then just make another duplicate if you need to. But once I've got it, you're going to go to export, and you're going to export STLs. It's just easier. OBJs, they give you a zip file and you have to unzip it. It's like extra clicks that are unnecessary. So you just do an STL. Now, the one thing about Tinkercad, you see what the name is here, sign example? That's what every file is going to be. So every file that I come in here to look at, downloads, right? Sign example 1. Well, this needs to change, obviously. So usually after I import it, I change the name right away. Sign edge. And then now after I have that STL saved in my downloads, come back here. And then this view here with the lines is the sliced preview. But this is the regular preview here. And you can pull more models back in. And so now I can do sign edge. And I can set the little edge cover, and then now I can print these. Well, okay, so this one is colored. You wouldn't want to print them simultaneously here, because watch, when I slice this one, it'll give me the same 3 colors. But ideally, you would print this one separate in whatever the single color is. But that's how you would pull it in. You would add a model, and then you can print them all at the same time if you need to. If you wanted to paint this yourself, right, then you can just print them all in whatever a base color is that you like. But yeah, so the workflow, you got your printer, you take it home, you find a model or you make a model, you pull it in, and then the last couple things that you need to think about are the type of plastic and the quality. And then beyond that is, do I need supports, or like they were talking about skirts and brims. You know, these are just different things to help make sure that your model comes out as expected. Infill, right? Secret, a lot of people talk about adding more infill. Unless you start getting to 90 to 100%, it doesn't really help the strength of the part as much as if you added more perimeters. And perimeters being these walls here. So if you see there's only 2 walls. If I change that setting to make it 3 walls or 4 walls, right, it'll make more solid exterior walls, and that will give you more strength. But for the most part here, you decide, okay, I bought ABS plastic, right? We talked about that earlier. So I want to print this in ABS. So I'm going to select ABS, and then I'm going to go, do I need any supports? Not for this model, so I'm not going to add any supports. But maybe, like, if this guy was flipped over because you just had to print it that way or wanted to print it that way. So I can place it by face. This is a cool thing too. So I can pick this face here, and then you can decide what face you want it to print on. So now if I was printing it this way, I would have to add supports. So now if I slice it, you'll see that it added some material here, right? You can see all this stuff in here. That's supporting that top lip. So now it can print in this orientation. But if I flip it over, I don't need to worry about supports, right? So you pick your plastic, and then you can go into the print settings and just verify, right? What is your layer height that you want to be on the first layer height? Do I want it to print faster or slower? Does it need to be stronger or thinner? You can make these layer heights even thinner than that. Like 1.5 is maybe the thinnest I would go, but I know other people have done thinner and seen some okay results with it. But again, with 3D printing, sometimes it requires like a test model. You print the test model and verify that it looks good, and then you can print more. And the more you do it, the better you get at understanding like what to do. So in these settings, I might know I want 3 or 4 because of how thin it is, and my experience in the past of how weak or brittle it may have been being as thin as it is. I'll add some of these to add some strength to it. But then so you want to verify the layer height, basically thicker layer heights like 0.3 or 0.4. 0.3 is probably what you'd want to do for speeding it up. This will decrease the time by like, I don't know, the 33%, 40%. And then if you want to go into the perimeters, like adding more solid plastic will increase the time a little bit. So you start learning these things, and don't let this scare you guys away. I like to tinker with these settings. There is a simple mode that kind of it takes some of these away, so you don't have to look at them and know what they do. And I don't play with most of these anyways. I have my favorite ones. I've played with a lot of this stuff. Some I either didn't understand as well as I'd hoped, or I didn't see the difference or variation. So over time, you learn this stuff. But the important part really is thickness dictates how fast, as well as how thick those layers will be. So it'll give it that 3D printing look. If I do something like this, it'll be much thinner and give you a little bit less of the 3D printed ribbed, outside exterior than the other one. But it also takes longer. If you can imagine 0.15 is half the thickness of plastic. It still has to create these layers, right? So if you look at the layer thickness, there's 34 layers on this one. And it's yelling at me, right? Stability issues. So this is cool new features. The sign edge, collapsing overhang, loose extrusion. So it's warning me like, hey, this guy's not going to print, right? So it wants me to change this. So that's good that the slicer is getting smarter now. But you can see down in the bottom right corner, there's a print time, and the print time's 1 hour and 28 minutes. But if I go into the settings, and make it a little bit thicker, and I reslice it. What did I do? Oh, I changed the first layer height. I'm sorry. So 0.15, here I am looking like a fool. Sorry, everybody. Let's get these settings in there correctly. So, okay, an hour and 44 minutes with the fine detail, right, 0.15. But then if I change this, so based on maybe I don't have time and there's a show coming up, or maybe I have all the time in the world, but it took 30 minutes off of the print time here, right? So about 33%, maybe a little less, 30%. So it increases the print time. So there are settings here, but for the most part, how good do I want it to look? Thinner layers if I want it to look better. How fast I want it to print, thicker layers. What plastic? This is the most important. You always have to pick the correct plastic that you bought, the one that you have hanging on your machine. If you pick the correct plastic, they maybe go in here and you might find, so let's say you don't use Prusa, right? You want to use somebody else's plastic. It may be a little bit, it might want to use a little bit lower temp or higher temp than what we have in here. This is generic ABS. And then Prusa ASA is very similar to ABS. They're like brother, sister polymers. So if I go to the filament settings, right, 260, it's real close. The first layer on the bed. So if you know that you're printing like a brand, or your printer for some reason doesn't love these settings, maybe you go 15 degrees cooler, 245 for your layers. So you have control, and it might be daunting for some people, but for others, like as you get to know it and as you get better, you're going to be happy that you have, like, if it's just not printing well, it's nice to know that you have a few things to try to get it to print correctly, right? So after you do that, you slice this guy, right? And then you export this G code. And depending on if you have it networked, you can send it right to the printer, or you can add it to a removable device down here and plug the USB right into the printer, or the SD card, depending on the model of printer that you have. So the MK4 and the Mini will use a USB, but if you have the MK3S, because that's the other thing we didn't really talk about, we still sell the MK3S Plus as well, and those are about, I think, $200 cheaper than the MK4s, and so that's another way to save a little bit of money in terms of, like, they're slower in terms of, like, they don't do input shaping, which is a newer feature that people are adding to software. Started with Clipper, or as far as I know, Clipper's the first one I heard of using it. It allows your printer to move faster without the, like, previous vibration problems causing defects that they had seen in the past. But the Prusa MK3X kit is kind of like right in between the Mini and this. So I know I said $799 for this guy, but the version that we have for this one, that's the predecessor, which is still, I think, the last 5 years was one of the best printers on the market. Everybody was cloning it, and it still puts out quality prints. That one's $649, and then this one's the Mini here is $459. So it's kind of like right in between the two. It's priced right in the middle. So it's probably worth the $200 to get the MK4 with all the brand new the stepper motor drivers and all the features that they've added to increase reliability, speed, print quality. Even though the MK3S is like a very good printer. So you guys have some options, but in terms of what you do here, You can pick whatever printer that you own. So I have the MK3S here, but I can grab the MK4 or the Mini, right? So if I transfer these settings, so because I have multiple printers, if you notice here, it pulled me right back to, you see the different build plate? That build plate is the Prusa Mini. And so just to show you a little bit of like the difference between the two printers. So you have that guy with that surface area, and then the MK4, which is the slightly bigger one. Transfer all these. Then you have this much more build volume or room to add, other prints or bigger prints. But in the slicer here, you can pick, right? So I have different profiles for different printers in here. And basically, you want your model. You want to know what material you're using. You want to know what printer you're putting it on. And then you want to know how fast you need it to print. And once you have all those plugged in, you can just verify the plastic temps. And a lot of time on different manufacturers, they'll give you a temperature on the box that says like what the range they expect you should be able to print with it. And maybe you need to adjust it, maybe you don't. But this is, you have control to go kind of verify these settings. And, what is the whole thing? Measure twice, cut once. So that definitely applies here with these printers. But for the most part, if you take your spool of filament, this guy says nozzle temp 215 plus or minus 10 degrees Celsius. Heat bed temp 50 degrees plus or minus 10 degrees Celsius. So you'll plug those numbers from the filament into your slicer. And so if I'm using PLA, which is what that was, come here to PLA, and then I'll just verify in my filament settings. I think I told it to transfer, but it said 215 plus or minus 10, and then 50 plus or minus 10. So maybe I want the first layer to be a little bit hotter and then drop this down to 50 or 55. And some of it is so minuscule, it doesn't change. Like you have some variation. It doesn't have to be exactly 60 degrees Celsius, right? But once you have all these settings in and you slice it and you export it and you put it onto your printer, then you just come right over to here, play with the menus, tell it to print, and let it go. And then, for this print in particular, it would be an hour and 15 minutes later, you'll have the sign and the cover for the sign. So sorry, okay. I know that was a lot. I know it wasn't linear, but I tried to get you all the information in there.
Yeah, he wants to know if there's classes for classes or beginner tutorials for Tinkercad.
Yeah, there's a lot of stuff. Tinkercad's website's been actually starting to do some classes and things. Their YouTube, Autodesk is the main company. Their YouTube channel has been doing some Tinkercad. But I think it's like a Tinkercad to transition into Fusion. And they have added a really cool feature to import Tinkercad files into Fusion. So those classes might be a little bit higher level, but there's definitely a lot of YouTube basic stuff. You could try and find a channel. A lot of the stuff seems like people do projects like, here's how to do this thing in Tinkercad. And if you don't even know where to start or what the name of it is, right? Like, oh, I want chamfers on a part. How do I do that in Tinkercad, right? You might, if you don't know what a chamfer is, then you don't know to look for it, right? So I haven't necessarily found a good resource for Tinkercad, like just straight, like from start to finish. I used to run Tinkercad classes, and actually I can give Tom a file that I made for some students in New York. I did a little like 2D model, like how to turn this into that. And it's a 2D like tent. That's like more like a TP, but basically I took that 2D image and I recreated it in Tinkercad and showed like all the steps for how to create that thing. And I was trying to pick a model that kind of went over a lot of the basic tools to kind of touch on everything. So if you want, I can give that to Tom to share with you guys. And then also, I mean, if there's enough people, I don't have a ton of free time, but we can maybe schedule something like a intro to Tinkercad kind of thing. But preferably I'd like to do that in a group, so I'm not doing like 15 different classes, right? Do it all at once. But if not, if we can't set something like that up, there's a lot of stuff online. There's some, I don't know, lynda.com or what, some of the previous ones. There are sites like that offer classes, masterclass type things that people have paid for, Tinkercad classes. And then there's a lot of, like, there's everything you need to know on YouTube. It's just kind of all over the place. If you're lucky, you'll stumble across Tinkercad, like basics from start to finish, and then it'll get you there. But either way, we'd like to help out the community. So
if anybody's interested in a class, send me an email, workbenchwednesday@gmail.com, and see how many we got, and see if Logan's up to doing a class for y'all.
Yeah. If we can get a group together, 100%, I'll do it.
Okay. Here's another question. Trying the mouse ear method on my model will know in an hour plus.
Awesome. Cool.
Okay.
Just make sure the mouse ear is down to the plate, just like the model, so it's touching.
Okay. A couple of more questions here. All right. Any possibility of a price reduction to compete with Creality or any Cubic, like a promo code Logan or something like that?
So the easiest way to do it is if we're at a show, they give out promo codes at the shows. So if we're ever at a 3D printing show, I can get like vouchers and things, but I think the max I've ever seen is 10% off. It's tough when you have a race to the bottom model and you have companies doing volume with injection molded parts and they're not paying as much attention to engineering. And I'm speculating here. I really have no idea how these other companies are manufacturing their products. I've only worked for one other 3D printing manufacturer prior to Prusa, and so I kind of know how one of the other U.S. companies does it, but not how the other overseas companies do it. I just know that we pay a lot of attention to detail and paying, very qualified people to pay attention to like in-house manufacturing tolerances. And it's one of those things, like if I go to Harbor Freight, I can buy a square, but if I want it to be like a precision square, right? Like a machinist square, it takes different machinery knowledge and whatnot. So I really wish we could make it more affordably, but right now as it sits, it's not a huge discount culture is not a huge thing for us, because one, we pride ourselves in the services, and two, we're paying people for support, right? That's people that aren't having anything to do with the manufacturing, but we have teams there, and so we don't charge for that. So where other companies, my previous company, like, in order to get that support, you could get it, but you were on the back burner. But if you paid like $4,000 a month, these for industrial printers, right? You'd have access to these people, but Prusa doesn't charge anything for it. Whereas the last company charged $4,000. Well, paying for those service plans was paying their salaries. We have to pay those salaries with the printer sales and whatnot. So, and filament and resin and all that. But honestly, I think if you're into thinking about it from a value perspective, right? We provide so much value all the way around holistically, and I think it's well worth it. Like, I know I work for them, but this is the same thing I would have told you before I worked for Prusa. Like, the reason my print farm went to Prusa's was just the value proposition was there, where I had less headaches. I had more help if I had a headache. And it just, you can just take it from me, believe it or not. Since I'm wearing this, maybe you'll think I'm just shilling for the company, but I have so many that sit on the shelf that I need to get rid of. And they were just a headache, a thorn in my side. And it's probably not worth the money to pay, because with 3D printing you can buy other components, new motherboards, sensors. You can modify them to be more up to date, but the amount of money it would cost me, it'd just be easier to buy more Prusas. So, and then have all those features. But take it from me, I'm just one guy, and obviously I work for them, so grain of salt. But I'm trying to convince you guys that I would have had the same perspective. That's why I went to work for this company, is because I believed in them and what they do, and I would have said the same thing before I started working for them, that the value's there. It's just hard to see if you haven't been a part of that journey of, starting with the entry level stuff and some of the headaches that these products correct. So.
All right, you were earlier. You were talking about trying to go to more train shows, and while
Yep.
you said that, Sparky came up with, "Are you going to Amherst?" Which
I would
is
like
in
to.
Springfield, Massachusetts.
I would like to. I have one other event that I have to verify. That's in Florida, that they don't conflict on the same weekend. I sadly, before I got permission to go, I didn't get a booth, and it sounds like Amherst is one of the more difficult. Like, you have to sign up well in advance. I'd love to just have a booth and have our products, but I will most likely, not 100%, but attend and just go and maybe if the coordinators or anybody knows can give me in touch with the coordinators, they're okay with me bringing some like things to hand out, give away. Maybe I can try and get some of these flyers to bring with me or something. We can get like a handful of discount codes for your community. I'll see what I can do. But I will probably go attend, see what it's about, and then next year exhibit at Amherst, because
Amherst is
like
probably the biggest show for model railroaders, so that would get a lot of exposure there.
Yeah, so I think the plan was to exhibit this year, but I didn't realize how soon I had to get, and I found out about them not like, I think October maybe, and then by the time I got sign off to go, it sounds like they're already full up. So if there's a way to get a table, I'll bring stuff, but if there's not, I'll attend and maybe just bring some giveaways like prints or swag or something I can get my hands on to bring with me.
All right, here's another one. Does Prusa have a free version of the slicer and a paid version?
No, it's all free. Everything's open source on the
Open
slicer
source,
front.
Yeah, okay.
Yeah, so that one is, you could go download it tonight and play with it if you want. Like, you could literally right now go get Prusa Slicer, download it on your computer, go to printables, grab a model, import it, and just play with the settings like we were looking at on here, and start getting your toes wet on 3D printing.
Okay, I misspelt my email, so I got to rewrite it in here. Okay. workbenchwednesday@gmail.com. I have a QR code here somewhere. I'll put it in the community tab so you can see it and let everybody know about it. And let me see if there's any other questions here. Okay. Yeah, we were talking about Prusa sounds like the Snap-on of 3D printers.
We were viewed that way for a long time, and the landscape is getting pretty competitive now. But that's a good thing. Everybody wins when it gets competitive. So
yeah,
you can't really be mad at it, right? It forces our hand to be a little bit more innovative and find solutions. So it's a good thing for everybody. The community will win from other companies coming in and adding more features and pushing the limits of the software and the hardware, and forcing us to also find new ways. It'll lead to the growth of the community, the technology, and hopefully printers that are more set it, forget it, and can do crazier things than these printers can do today. So.
Okay, and Sparky had a plug here. Make sure you check out the Mini Prints booth
Oh, awesome.
at Springfield.
Oh, perfect. Yeah, that's 100%. Yeah, that'd be cool.
And great show. Thank you, Tom and Logan. Very informative. Awesome presentation. Thanks very much. Well
Appreciate it.
presented and informative. And Jim has another question. In your opinion, is Prusa Slicer better than the Cura Slicer?
I like it better. And the reason being, you still have a lot of advanced features. Cura has like a ton of advanced features as well. And some of the stuff I was trying to get into the weeds of like the advanced and experimental settings. And they both work well. For some reason, the workflow for me with the Prusa Slicer just is more intuitive for me. There's a lot of people who love Cura, and I think sometimes it's just how things are presented in the user interface. Like, I just liked the Prusa printer one better. And yeah, so that's where I stand on that. I think they're both wonderful. They both get the job done. It's just my preference that Prusa was more intuitive and easier for me to work my way around and use. So that's why I gravitated toward it.
All right. Is that I don't see any more questions up here. I think you covered a lot in the 2 hours that you've been talking there.
Yeah.
I think you answered everybody's questions.
Well, that's good. Yeah, I don't know that I planned for it to be 2 hours when we started, but we're here.
Well,
so.
I told you could have as much time as you wanted.
Yeah, that's perfect. I didn't even know. I was like, man, I don't know if I could even fill it. Like, I don't even know if I know enough to fill 2 hours worth of time, but here we are. So
Yeah, so very informative, and I'll get that list together. And if you could send me an email with that information, I'll pass it on to the viewers here. And workbenchwednesday at gmail.com. Send in your email if you want to have a class, and we'll see how many we can get. And I'll talk to Logan to see if he'd like to do that.
yeah. 100%.
Okay, did he answer the preferred format? FDM versus resin for the different scales?
Is this the kid that's asking for homework now at the end of class? It depends. That's an it depends answer. FDM versus resin is based on like the material properties, the scale or size, right? Resin's much better doing smaller things. So for senior Zen scale layouts, right, the resin's going to be a lot easier for him to get the tiny parts. Because it's the width of the plastic that comes out of the nozzle makes it hard to do like an elk or something, right, at N scale, because the blob of plastic that comes, the extrusion itself is already so thick you can't get those fine details. Whereas in resin, like it's the pixels on the screen that are masking are so tiny. You're talking microns, right? Like 50 microns or less on a lot of these printers these days. And so you have 50 micron resolution, and then at a 0.4 millimeter nozzle, you have a 400 micron resolution, right? So it makes it real hard to get those tiny details. So that's where I was kind of trying to hedge my explanation and my bets there. HO plus, I think you have a lot of use for FDM. There are larger buildings that FDM work for in N scale, and I've printed some stuff for N scale and FDM. So it depends, right? If you're going real tiny, the N scale or FDM can't do it. So if you're making animals and small cars and things, then resin's your choice. Buildings and for N scale, I would say buildings are where you would start, where FDM's fine, and then any scale beyond that, HO, GO, things like that, then you can use FDM, maybe even for the cars and the animals and what have you. So.
Okay, I have one last question, and I think we went over this when I was talking to you last week. But is there any any printers that have a battery backup in case you lose power that you continue on to print?
Yeah, good question. I don't know if one comes like pre-installed on a printer, but I did get a good deal. Costco had some on sale not too long ago. You can find some deals on the internet. I know TripLite is a company that we used to use. They're a little more expensive, but my last company used TripLites. But other than that, if you can find anything that gives you a little bit more time, so if you live somewhere like in Florida during hurricane season, you might want to have it and do like a battery backup. I put surge protectors on all my machines. I started like, it just seemed like a no-brainer. Now I think I'm up to like 22 printers now or something like that. I'm a degenerate and have a problem, but I now have like 6 different surge protectors at a minimum to protect from any type of electrical surge and damage. But I did start acquiring battery backups, and those are more so if you have really long prints. Like if you want to start doing stuff that takes 48 hours or more, you're going to want to maybe have a battery backup kind of thing. This is a lot of time and material to lose. And for like $150, right? I don't know. It may take some time to get there depending on how much you print, but it is beneficial. Power goes out. You have another 30 minutes, hour, whatever the runtime is based on the size of the battery backup you get, to where you don't have to worry about your printer or your print dying. Maybe you have time for the power to be restored. And then if not, then you have to try and rely on the recovery feature and that nothing shifted on the build plate. But even with recovery features on a lot of these printers, typically, and I don't care what anyone says, go on YouTube and find these videos of people doing the tests and or they had prints fail. Like you'll get some kind of blemish, some small layer shift, right? None of the printers are like perfectly accurate these days. So getting back onto a print that is cooled down and then reheated back up, like things shift. And that's one of the few things about 3D printing. But if the print goes well though, like everything should come out, wonderfully, and you have a nice model to paint, play with, and add to your layout.
So depending on the print size, if you have a large print, you better get a bigger battery backup.
Yeah, if you're building something giant. I think the last thing before I go, I was looking at, I for some reason thought it would be printable. And then after I did the calculations, I was like, yeah, no, I can't do that. I was looking at, I used to be in the Navy, so how big would an aircraft carrier be? I'm like, surely I can 3D print an aircraft carrier in N scale, right? In N scale, I'm thinking like, yeah, it was like, I could print 2 halves of it. It's like 6 or 7 feet, man. Yeah, no, I guess I'm not printing any aircraft carriers for anybody's layouts. That thing's giant, man. So
multiple sections.
Oh yeah, it would have taken forever. I was like, I'm good.
Okay, yeah, I think everybody else is just saying thank you in here. Alrighty. My entire home is on Tesla battery backup system. If power goes out in the entire house, it's a battery backup, and you do not even know it happened. Oh, there you go.
That's a great house to be 3D printing in then.
Yeah, there. All right. All right. So very, very informative. I want to thank you very much for doing this presentation. It was very helpful.
Yeah,
and I know a lot of people learned a lot of things here. And I'll get back with you with that list, and I hope you could send me that one file that you were talking about, and I'll send it on to the viewers here. So I'm going to end this thing with the with my usual outro, so we could have the swirly smoke. And Jim says he wish he had that whole house battery backup. Don't we all?
Yep.
Okay, so I think that's everything.
Yeah, thank you for having me. I appreciate it. I enjoyed it. So
nicely done, and a lot of info to digest. Okay, there you go. And there's a great show. Okay, I'm going to do the outro right here. Thank you very much, Logan, and we'll be talking to you pretty soon.
Definitely.
Okay, take care.
See you guys.
Engineer, where are you headed? Carry me back to Tennessee. Oh, I got a little girl who's been waiting. Promised that she'd marry me. Mister, can we leave that seat? I'll shovel coal, Lord, to pay my fare. Gotta get this train down to the station. My little girl waiting for me there. Well, the night is dark and Lord, it's cloudy. I've been traveling that lonesome road. My one true love waiting at the sea. Won't that low train carry me back?
Here comes the swirly smoke.
Well, they left Columbus around 7. Oh, Lord, they hit Louisville about 9. That poor boy's heart started overheating, sending all of his love on down. For the night is dark and Lord is bright. I've been traveling this lonesome road. My one true love waiting at the sea. Oh, that long old train back. For the night is dark and the sky is cloudy. Traveling on that lonesome road. I want
No after show on Rumble tonight. It's been a long show tonight.
For that long old train, won't you carry me? Oh,
Train, 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 won't you carry me home? Whoa, whoa. Good night, everybody. We'll see you again on Wednesday. We'll have an after show then, and we'll have some more information then also. Thank you all for stopping in. I really appreciate it. Take care, everybody. All right, let's cut this thing off here.